Alright, so we want to find the volume of this parallelepiped using the scalar triple product, which is this over here, which is the vector A dotted with the cross product of the vector of B and C. Okay, so given three vectors we need to find that define a parallelepiped, we need to find the volume of the parallelepiped defined by these three vectors. So let's first understand where this equation comes from. So we have volume is equal to, now in a parallelepiped, it's basically a parallelogram that's a prism. Okay, so we have the area of a side times by the height. That'll give us the volume. Okay, well, the area of one of these sides is going to be B crossed with C. B crossed with C, the magnitude of that will give us that area over there. So for area, we can substitute in B crossed with C, the magnitude. Okay, now what about this height? So we are looking for that height over there, when this angle between the height and the vector A is theta, and that's 90 degrees. Well, what does that mean? That means that cosine of theta is equal to the adjacent side, which is the height, over the magnitude of vector A, which is the hypotenuse. So what does that leave us with if we remanipulate this? That means that H is equal to the magnitude of A times by cosine of theta. So for height, we substitute in the magnitude of A times by cosine of theta. But you'll notice that the magnitude of a vector times the magnitude of another vector times by cosine of theta, or cosine of the angle that is between these two vectors, is just the same as the dot product. So that then simplifies to the dot product of A times by the cross product of B and C. So this is how we essentially derive our formula for the volume of the parallelepiped. So let's use it now to calculate the volume of a parallelepiped that is defined by these three vectors. Okay, so it doesn't matter which vectors you choose for A, B, and C. So let's randomly choose this vector to be B, this vector to be C, and this vector to be A. So first we need to calculate the cross product of B and C. So the cross product, we use a determinant, and we put in our vectors. So now we're going to put in the vector B over here, which is 4, 1, and 1. And we put in the vector C over here, which is 1, 2, and 1. So this equals to something times by the unit vector I minus something times by the unit vector J plus something times by the unit vector K. And for this something for the unit vector I, we take out this row, this column, and then we say 1 times 1, which is equal to 1, minus 1 times 2, which is equal to 2. Okay, now for the jth one, we take out this column, and we have 4 times 1, which is 4, minus 1 times 1, which is 1. Okay, now for k, we take out this k column, and we have 4 times 2, which is 8, minus 1 times 1, which is 1. And that becomes 1 minus 2 is negative 1, so we have negative I. And then 4 minus 1 is 3, so we have negative 3j. And 8 minus 1 is 7, so we have plus 7k, which is just the same as the vector negative 1, negative 3, and positive 7. Okay, so now we have this vector B cross C, and we need to do the dot product of that vector and the vector A, which we said was 1, 1, and negative 1. So A dotted with B cross C, which is that vector, is going to be equal to, now we said A was 1, 1, and negative 1. So we have 1, 1, negative 1, dotted with the vector negative 1, negative 3, and 7. Okay, so 1 times by negative 1 is negative 1. 1 times by negative 3 is negative 3, and negative 1 times by 7 is minus 7. And minus 1 minus 3 minus 7 is equal to negative 11. And in the case that you do get a negative answer, you should take the absolute value because volume is strictly positive. So the absolute value of that is equal to 11 units cubed. And that is the volume of the parallelepiped that is defined by the vectors A, B, and C as shown on screen. I hope you found this video useful, and I hope you found it enjoyable too. And if you did, please don't forget to leave it a like and subscribe to my channel. It really does help me out.